hydrides. Next is hydrides. The dihydrogen under certain reaction conditions combine with almost all elements except noble gases. So there is except noble gases to form usually binary compounds. They are called hydrides. Suppose the hydride can be expressed like this. Usually element where E indicates elements H2. Example E magnesium hydrides. Okay, or simply we can write EMHN. Okay, that is E element boron was using the non-metal boron B2H6. Okay, the hydrides are classified into three categories. That is, one is ionic or saline hydrides. Second is covalent or molecular hydrides. Then third is metallic or non-stoichiometric hydrides or interstitial. So this is the classifications of hydrides. First we will see the ionic hydrides. The ionic hydrides are these are the stoichiometric compounds of dihydrogen formed with most of the S block elements which are highly electropositive in character. See, however, the significant covalent characters found in the lighter metal hydrides such as the lithium hydride, beryllium hydride, magnesium hydride, like this. Okay, so in fact the beryllium hydride and the magnesium hydrides are polymeric in structure. The ionic hydrides are crystalline, non-volatile, and the non-conducting in solid state. However, the metals conduct electricity and on the electrolysis liberate the hydrogen gas at anode, which confirms the extensions of the hydride ion, that is 2H minus, that is in molten state or melt. At anode, this is at anode, gives hydrogen and 2 electron, because anode means loss of electron. Then the saline hydrides react violently with water, producing the hydrogen gas. When react with metal hydride, sodium hydride react with the water to produce sodium hydroxide and the dihydrogen gas. Then lithium hydride is rather unreactive at moderate temperature with oxygen or chlorine, like that. It is therefore used in the synthesis of the other useful hydride, like examples of lithium hydride react with the aluminum chloride. There is the dimer form of ACl3 to form lithium aluminum hydride, and lithium chloride. Then the lithium hydride, 2 moles of the lithium hydride react with the diborane B2H6 to form lithium borohydride. Okay. So this is the ionic hydride. Then next is the covalent or the molecular hydride. Next is the covalent hydride. The dihydrogen forms molecular compounds with most of the p block element. So most familiar examples like methane, ammonia, water, like this. Okay, the hydrogen fluoride. So for the convenience, hydrogen compounds of non-metals have also been considered as hydrides. So being covalent, they are volatile compounds. So molecular hydrides are further classified according to the relative number of the electrons and bond their Lewis structure. So usually they are classified into three types, that is electron deficient, electron precise, and the electron rich. That's mean electron deficient hydride, electron precise hydride, and the electron rich hydride. So the electron deficient hydrides, as the name suggests, has too few elements. There is few electrons by writing the conventional Lewis structure. That is the diborane is the example, B2H6. So that is the diborane. In fact, all elements of the group 13 will form electron deficient compounds, okay, because they act as a Lewis acid, that is the electron acceptor. Then the second is the electron precise. The electron precise hydrides compounds have the required number of electrons to write their conventional Lewis dot structure. All elements of this is the group 13 elements. This is the group 14 elements. The compounds like methane, which are these tetrahedrally geometrical arrangements. Then the electron rich hydrides have the excess of electrons which are present as lone pair, that is unshared electron pair. So elements of group 15 to 17 form such compounds like ammonia. See, the ammonia having one lone pair of electron, then water molecule, that oxygen having two lone pairs of electron, then similarly in hydrogen fluoride 3 lone pairs of electron. Okay, because they behave as a Lewis base, that means the electron donor. The first one is the Lewis acid. This is the Lewis base. Lewis acid means electron acceptor. This is Lewis base means electron donor. That is why the electron rich. This is the electron deficient. Electron precise is it's a perfectly arrangement. That is the methane. Okay. Then next is the metallic hydrides. So this metallic or the non-stoichiometric hydrides. See, these are the metallic hydrides formed with many D block and the F block element. However, the metals of the group 7, 8 and 9 do not form hydride. Even from group 6, only chromiums form, that is chromium hydrides. Okay. So these hydrides conduct heat and electricity, though not efficient as their parent metals do. Unlike saline hydrides, they are almost always non-stoichiometric, being deficient in hydrogen. For example, lanthanum hydride, titanium hydride, zirconium hydride, like this. Okay. Then, so this is the metallic hydrides or the non-stoichiometric hydride. Okay. The next is water. Water, the molecular formula is H2O, well-known compound. A major part of all living organisms is made up of water only. So the human body contains about 65% of the water molecule, and some plants have such have as much 95% of water. So it is crucial component for the survival of all life forms. Okay, so it is a solvent of a great importance. The distribution of water over the earth's surface is not uniform. Okay, that is the estimators of the world water supplies in the source ocean. The percentage is 97.33%. Lakes, inland seas like 0.008%. Polar ice and glacier 2.04%. Groundwater is 0.6%. In lakes only means 0.009%. Soil moisture is 0.005%. Atmospheric water vapor is 0.001%. And river is 0.0001%. So this water, that is the occurrence. Then the physical properties. So the physical properties of water, it is a colorless and the tasteless liquid. The unusual, the properties of water in the condensed phase, that is liquid and the solid states, are due to the presence of the extensive hydrogen bonding between the water molecules. So this leads the high freezing point, high boiling point, high heat of vaporization, and high heat of fusion is comparison to hydrogen sulfide and hydrogen selenium, H2S and H2SE, hydrogen selenium. So in comparison to other liquids, water has a higher specific heat, thermal conductivity, surface tension, dipole moment, and the dielectric constant like this. See, these properties allow water to play a key role in the biosphere. Okay. See, then the high heat of the vaporization and heat capacity are responsible for the moderation of the climate and the body temperature of living beings. It is an excellent solvent for the transportation of the ions and molecules required for the plant and animal metabolism. So due to the hydrogen bonding with polar molecules, even a covalent compounds like alcohol and the carbohydrate dissolve in water. Okay, many of the carbohydrates like glucose, okay, covalent compound like alcohol, so they are also dissolved in water because of the hydrogen bonds formation. Then the structure of water. Structure of water. So in the gas phase, water is a bent molecule with bond angles like this is the bent form. The bond angle is 104 degree, 104.5 degree, and the OH, this OH bond length is 95.7 picometer. Okay, it is highly polar molecule. So that means they have partially positive, this is partially negative, and this is partially positive. This is the orbital overlap in water molecule. So these are the three structures. That is there is a water structure like this. It's a bent form. It is a bent form of structure. Then the highly polar. This is the polar like partially positive and partially negative, and this is hydrogen also the partially positive charge, and the overlap picture of the water molecule. That is the orbital overlap. So the crystalline form of water is ice. At the atmospheric pressure, ice crystallizes in the hexagonal form, but at very low temperature it condenses to cubic form. So density of ice is less than that of water. Therefore, ice cube floats on water. So in winter season, ice formed on the surface of lake provides the thermal insulation which ensures the survival of the aquatic life. So this fact is the great ecological significance. Then the structure of ice, you can see the structure of ice in your textbook. That is, the ice has highly ordered 3-dimensional structure. The hydrogen bonded, usually the hydrogen bond structure like this. The examination of ice crystal with the X-ray shows the each oxygen atom is surrounded in the tetrahedrally by 4 other oxygen atom at the distances 276 picometer. So the hydrogen bonding gives the ice a rather open type structure with wide holes. So these holes can hold some other molecules of the appropriate size interstitially. Okay. So these are the physical properties of water. Next class we will discuss the chemical properties of water.